Good day, students. Today we are going to discuss topic titled speed, velocity, and acceleration. And under it, we are going to be discussing uniform speed, uniform velocity, and uniform acceleration. Now let's start with speed. Speed is the rate at which a body covers a distance. That's what is called the speed of the body. When you are talking about rate, time is involved. That means that speed equals distance over time. The SI unit of speed is meter per second. Don't forget that speed is a scalar quantity. Okay, now let's go to displacement. Displacement is defined as the distance traveled in a specified direction. Specified direction, you are going to give us a particular direction at which the body moves. For example, when you say a man moves 2 meters due north, because of the due north you have introduced, is now 2 meters is a displacement. But when you don't involve the direction where the man goes, that means that it's a distance. Take note. Now let's see the third one, uniform speed. When a body covers equal distance in equal interval of time, no matter how small the time interval may be, the speed is said to be uniform or constant speed. For example, when a man moves like 2 meters, he moves 2 meters, he moves another 2 meters, he moves another 2 meters, that is equal time interval. Okay, when you say a body covers equal distance, when you are talking about uniform or constant speed, you say a boy or an object covers equal distance in equal interval of time, no matter how small the time interval may be. It is referred to as uniform or constant speed. It is very important you introduce when the body covers equal distance. Equal must be there, equal distances. And you have to cover 2 meter, 2 meter, 2 meter at a particular equal time interval of the coverage of equal distances. That's when uniform has to come in, uniform speed. Please, when you are defining it, definition is different from speed. And also the SI unit is still meter per second. Now let's go to velocity. We use bar V, likewise the way we use it for speed. Bar V, it is the rate of change of displacement with time. Can you see when you are talking about velocity, you use rate of change of displacement with time. But when you are talking about speed, is the rate of change of distance with time. Velocity equals displacement over time. Its unit is meter per second. Velocity is a vector quantity. What is the difference between scalar and vector quantity? Scalar quantity are those quantities that has only magnitude but no direction. We have discussed that before. That when something has a magnitude, you don't tell it has no direction of saying whether it is due north, due east, due west, and the rest. Is that okay? That's scalar quantity. But when it indicates the direction where the object moves, that's when it's now vector quantity. See, it has velocity, the rate of change of displacement with time, and velocity equals to displacement over time. Its unit is meter per second. Now let's go to uniform velocity. Very synonymous to uniform speed. When the body moves or covers with equal displacement in equal time interval, no matter how small the time interval may be. What's the difference between uniform velocity and uniform speed? When you are defining it, you said the body moves with equal displacements. There will be equal displacement here, but under uniform speed, we are going to make use of equal distances because the speed is a scalar quantity. Equal distances. Here under uniform velocity, equal displacement in equal time interval, no matter how small the time interval may be. Its unit is meter per second. If the body moves around a circular path at constant speed, moves in a circular path at constant speed. This is the object move in a circular path at constant speed. It is said to move with non-uniform velocity because its direction of motion is constantly changing. The direction of motion is constantly changing. That's non-uniform speed or non-uniform velocity. Is that okay? Now let's come to acceleration. Acceleration is the rate of change of velocity with time. Okay, its unit is meter per second squared. Acceleration A equals change in velocity over time taken for the change. A, acceleration equals final velocity minus initial velocity over time. And see, I brought the alphabet out. V is to represent final velocity. U is to represent, we use U to represent initial velocity over time. A equals V minus U over T. You cross multiply. V minus U times 1 give you V minus U equals AT. Collect the line times. We want to make final velocity to be the subject of the formula. V equals to U plus AT. A stands for acceleration, T time taken, U initial velocity, V final velocity. Now let's go to uniform acceleration. When the velocity, acceleration deal with the velocity over time taken. We now say when the velocity of a body increases by equal amounts in equal intervals of time, no matter how small the time interval may be. Is that okay? We are still using the same definition but different terminologies inside. When under acceleration, you use the definition of velocity when the velocity of a body increases by equal amount in equal intervals of time. I told you when you are dealing with uniform, you must introduce whether velocity or speed, uniform velocity or uniform speed or uniform acceleration. You must introduce equal amounts in equal intervals of time. The only difference is that you have to take note of when to use velocity, when to use displacement when you are dealing with velocity, uniform velocity, and when you are dealing with uniform speed, you use equal distances. That's just what needs to take note. Okay, no matter how small the time interval may be. Example 1, let's solve a problem under that. What is the average speed of a bus covering a distance of 200 km in 2 hours? You will notice that these units are not standard, they are not SI units. Now let's try to convert it. The first one, 1000 meters equivalent to 1 kilometers, 200 kilometers, 200 kilometers to what? To x. You cross multiply x times 1, that's x equals 200,000. You multiply it, convert it to meters. 200 times 1000 give you 200,000. Now you have gotten that distance. That's our distance. Let's call it, okay, let's call it D, distance. Okay, covering a distance of this time, that's 2 hours, which is 2 times 60 minutes make 1 hour. Don't forget that this one is just when you say 2 times 1 hour, which is 2 times 60 minutes make 1 hour. 60 minutes make 1 hour. You want to convert to seconds. 2 times 60 times 60. Okay, you have that one in seconds. In seconds, you have converted it to seconds. Okay, what are we looking for? Average speed. Average speed equals distance, total distance over total time. And we are looking for average speed. What's our total distance? You have 200,000 over total time. 2 times 60 times 60. 0 cancels 0. 0 cancels 0. 2 here, 3. 2 here. You have 1 0 0. I have another 0 here before. We have 2 here, 3, 2 here, that's 500, 2 here, 1, 2 here, 250. Okay, you have average speed. Average speed equals 250 divided by 9. When you press your calculator, you have 27.78 meters per second. Convert to the standard unit. Is that okay? Convert your time to seconds by multiplying it 2 times 60 times 60, and then do your divisions the way I did it. That's your average speed. The second example, a car travels average speed. Given average speed equals 100 kilometers per hour. Okay, let's convert it to the standard, which is 100 times 1 kilometer divided by 1 hour, which is 100 times 1000 meters make 1 kilometers, divided by 60 times 60, convert it to seconds. Okay, now let's do some divisions. Now 0 cancels 0, 0 cancels 0, 2 here 3, 2 here 5 0, 2 here 3, 2 here 5. Average speed equals 250 divided by 9. When you get that one, you have 27.78 meters per second. Okay. What distance does it cover? We are looking for distance. Distance. We don't know that one. Question mark. That's S. 5 minutes time. 5 minutes, which is T 5 times 60 in seconds. Okay. Now average speed equals distance over time, and we are looking for distance equals to average speed times time. Average speed times time. Okay, our distance now equals, what's our average speed? 27.78 times time, 5 times 60. Distance S. When you multiply it, you have 8,333.3 meters. Okay, 3 meters. That's the end of our class. Please subscribe to my channel so that I can have access to the latest video. Have a wonderful day.